So in this video, we are going to apply the 68, 95, 99.7 rule to a couple of different questions. So in this first question, we have that in a normal distribution, the mean recovery time after contracting a disease is 12 days with a standard deviation of 2 days. Now, before we do anything, I have drawn in my normal distribution here, and I'm going to label the parts down the bottom with the information I'm given. Now, this is a good way to kind of first just write in your mean, but this gives you a reference point that you can refer back to, which makes doing the actual questions themselves easier. Now, each standard deviation is marked by these dotted lines, and it gives us in the question that our standard deviation is 2 days. So our mean always goes in the middle of our normal distribution, and then our standard deviation. For each standard deviation we go across, we add the amount we've been given here on this side, and then we subtract going down on this side. So it's saying in part A, how long would it take for half the patients to recover? So we know that the normal distribution is symmetrical about the mean. So 50% of the scores lie above this mean of 12. So anytime it talks about half, it's just talking in terms of the mean. So we're just going to write 12 days here. Now, it's saying in part B, what percentage of the patients would recover within 8 to 16 days? So 8 to 16. We can see that this is within 2 standard deviations of our mean. 1, 2 above and 1, 2 below. So based on our rule, we know that within 2 standard deviations of the mean, 95% of the data is there. So because it's within 2 standard deviations of the mean, I'll actually write that in. So it's 95%. Okay, next one. So we are saying here, what percentage of the patients will recover within 10 days? Okay, so within 10 days means 10 days or less. So we're looking at this part of our normal distribution. Now, let's ask ourselves a couple of things. We know that here, from here to here, makes up 50%. And these middle ones, within 1 standard deviation, this whole thing here is 68%. So just one of these will be half of that. So this one here is going to be half of that. So that's going to be 34. So this guy over here is 34%. Okay, so that means that the ones above 10 days, we have 50% plus 34%. So that gives us 84% above 10 days. So I'm going to write that first. So 34 plus 50 equals 84% above 10 days. So within 10 days, which is 10 or below, is 100 minus 84, which equals to 16. So 16% recover within 10 days. So we're just looking at percentages when we navigate our normal distribution here. So next one, if we reset here. So once you do this, we reset, we rub everything out, and then we approach the next question. You may want to draw up a number of different normal distributions to help you with this, but it's saying that if 400 patients contracted the disease last year, how many recovered within 16 days? So let's actually just write part D here. Now it's saying how many recovered within 16 days. So that means we are looking for within 16 means 16 or less. So this entire section and everything below. So we can either just count everything here, or what we can do is we can figure out what the percentage above 16 is going to be. Now, we know that the percentage above 2 standard deviations is going to be 2.5%. Because the reason we know that, if we imagine 2 standard deviations, let's actually just redraw this. Within 2 standard deviations is here. Now, this makes up for 95% of our data, right? So between this one above and this one below, there's 5% in total. So we divide that by 2, we get 2.5% and 2.5%. So if we wanted to think of this entire section, all we would have to do is just take 100% and then subtract 2.5% from it. So the percentage here, we're going to have 97.5% over 16. So we are going to, because we want to figure out how many recovered within 16 days. So we have to find 97.5% of 400. So we have to go 97.5% multiplied by 400, which equals 390 patients. So that's how we can start navigating our normal distribution. Let's do another example just to continue practicing. It's saying here that the distribution of delivery times for pizzas made by House of Pizza is approximately normal, with a mean of 25 minutes and a standard deviation of 5 minutes. So before we do anything, I'm just going to populate these dotted lines with some numbers. So the mean is 25. And it's a standard deviation of 5. So here we're going to go up by 5. So I have 30, then 35, then 40. And then I have 20, 15, and 10. Okay, so part A is saying what percentage of pizzas have delivery times between 15 and 35 minutes. Now, between 15 and 35, that's within 2 standard deviations of the mean, okay? So 95%, because that's the percentage within 2 standard deviations, that is going to be our answer. Anytime you see within 2 standard deviations, the percentage is going to be 95%. Okay, next one. It's saying what percentage of pizzas have delivery times of greater than 30 minutes? So the part we're looking for in our normal distribution, greater than 30 minutes. That's this part here. So once again, this part, under 25 is 50%. And then plus the extra 16%. If we go half of 68, we have 34. So we have 50 down here, and then another 34 here. So 50 plus 34, 50's here, 34 is just this one here. We have 16% being above 30. Because we do 100 minus 84, or 100 minus 50 minus 34. So that means that we have here, part B, 16% will be greater than 30 minutes. Now part C is saying, let's just rub this out again. Saying in 1 month, Pizza House delivers 2,000 pizzas. How many of these pizzas are delivered in less than 10 minutes? So less than 10 minutes, we are looking for a teeny tiny amount of pizzas, okay? So think about it. This is 3 standard deviations below, 10 is a score of 3 standard deviations below our mean of 25. This is all the scores that are less than that. Now, we know that within 3 standard deviations, it's 99.7%. So the ones outside of that, so either below 10 or above 40, is going to be 0.3%. So I'm just going to make a note of that. So below 10 or above 40 is 0.3%. Now, we're just asked for the ones less than 10 minutes. So just this tiny bit down here is going to be half of 0.3%, which is 0.15%. So taking that into account, let's make some more space here. To find the amount less than 10 minutes, we have to do 0.15. Oops. Yep. So 0.15 times 2,000. And that gives us 3. So there are only 3 pizzas out of the 2,000 that will be less than 10 minutes. And that kind of makes sense, right? This tiny bit in our normal distribution, this is like an outlier, right? This is like a really quick delivery driver who's able to get this in. We're just looking for percentages along our normal distribution when we do these types of questions. But hopefully this gives you a bit more confidence in navigating the normal distribution. This is how we can apply our 68, 95, 99.7 rule. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.